Hello everybody, my name is Mohit Deshpande, and in this video I want to kind of give you guys an intuitive understanding of convolution. And so I mentioned that convolution is kind of the operation that we apply using kernels to an image so that we can apply all sorts of cool filters and effects. So I kind of want to give you guys, an intuitive understanding of what it is, and we'll go through like a really small example, and then there'll be a more detailed example in case you like really want to delve into it. But that's just that the more detailed example is completely optional. But first of all, let's start out by defining what is convolution. So convolution at its core is a mathematical operation. So it's a math operation to apply a kernel to an image. And so right now this might not mean that much, and I'm trying to not get into too much of the details. I'm going to save that for the optional video, but let me at least give you kind of intuition behind convolution. So first of all, let's suppose that we have an image like this, and I want to perform some kind of operation on it so that I get this resulting image here, so that I can apply like some kind of effect to this. So then I can get this really cool looking image here with the effect applied, and this is going to involve our little smaller matrix or kernel or something, or kernel or our filter. So let me redo that. Okay, so kind of the intuition behind convolution is that so we can look at this image and we can divide it up into a ton of different pixels, and we can look at each pixel individually. Like for something like brightness and contrast, you look at each pixel individually and you apply that operation, or you can consider all the pixels together as a matrix. But the point is, with contrast and brightness operations like that, you really only consider a single pixel and you perform an operation on a single pixel independently of all of the other pixels that might be nearby, or on the other side of the image or something like that. But convolution is fundamentally different, because instead of applying this operation to just individual pixels, we actually look at neighborhoods of pixels. And so we might want to like carve out this portion of the image, and we look at this neighborhood of pixels. So suppose if we had like a 3 by 3 or something, then this is kind of like the center. So I'm gonna like color it a little bit so that this is kind of like the center, and then we look at the 8 pixels that are around this center point. So instead of just looking at this red pixel individually, we can also consider the pixels that are around it, so that we can get a better, it helps because we're considering the pixels around this particular one of interest. And this makes sense because when you look at an image, these pixels aren't all just randomly placed there, right? They belong to kind of larger and larger parts. So like if I had a picture of a bird or something, then and I look at one particular pixel, it's not it with convolution we don't treat it as being independent of the pixels around it. We treat it as being a part of the pixels around it. And so what convolution tries to do is it tries to consider the fact that the pixels that are influenced by those that are kind of around this center point, and then from that knowledge, then we can apply that effect over and translate it to this resulting pixel here. We perform one operation that involves the neighboring pixels, and then we compute a single value and put it over here. And so instead of looking at the entire image as kind of one whole thing, instead I say, well, wait, you can't look at the whole image. In fact, let me just give you a small window to look out of. So instead of looking at the image as a whole, we actually just get this little sliding window. And so we're not allowed to look at the whole image. We just get to look through this window, and we're not restricted to looking at just one portion of the window, or one portion of the image, we can actually slide this window around. This is a sliding window. We can slide it around our image and compute this value and say, well, look at this pixel and look at the neighborhood of the pixels, the 8 pixels that are kind of around it, including this pixel, and can I determine something about that using a kind of its surrounding areas. And so, you know, this works exactly like a window in the real world. You don't see everything. You just get to see kind of a small part of the image, and you want to make some evaluation based on that, and you move to the next small part of the image and you make some evaluation based on that. And then you just kind of keep sliding this over to the right and then down and then back to the left and then down, and then you just kind of keep sliding this window around and computing it till you fill in this image. And so that's kind of the intuition behind this, and the reason that I don't want to get too into this, but part of the reason that this works is because of the fact that you consider the neighborhood of pixels and not each pixel individually. So this is just kind of a very, very top level understanding of convolution. And I keep referring to this as a sliding window, but in actuality, this window, or let me not use an abbreviation for that. This window that we look at is actually the kernel. So we got to get this nice, so this kernel is the window that we're looking through, and so now our kernel has numbers in it, and our image has numbers in it because it's an image, and we have pixel values. And so, whoops. So in the next video, I'm actually going to go through a really small example, just kind of one computation, and so that you kind of understand how the values of the pixels in the image and how the values of the kernel kind of combine together to get you this singular number. But let me just going to stop right here, and I just want to do a very brief overview of convolution. And convolution is, like I mentioned, it's a mathematical operation. It's not unique to image processing, actually. It's been used for signal processing, but for image convolution, it's a way that we can apply a kernel to an image to produce a resulting image that has, it's altered from the original image, and it produces some effect. And how we do this, interestingly enough, is we don't consider each pixel individually like we do with things like contrast and brightness. We actually take a look at one pixel and then consider the neighborhood of like the 8 pixels that are surrounding it. And so now we get some more information about what to compute, and the surrounding of the neighborhood of pixels. We have a better idea of how, what features are kind of around this pixel. It gives us more information to make a better determination. And so this little window here, you get this little sliding window, and you can move it around anywhere you want in the image, and you compute a singular value. It's a single number, and that goes in the same position as the center pixel that you're looking at. And so now, like, each of these values kind of like goes here, and all of these values kind of affect the center here, like that. So this kind of produces the result of like applying filters and stuff. And so kernels, like I mentioned, we can use them for so many things, and this is how we apply them. Convolution is the operation that we use to apply our kernels to any image. And so this is just very, very, very top level overview of what convolution is. In the next video, I want to actually go through just a single computation of convolution, and then in the video after that, we're going to kind of go into a little bit more detail, and that video is completely optional, just for those of you that are really interested in that kind of stuff. So this is where I'm going to stop right here, and then in the next video, we're going to go through just a single example with convolution.